Hey guys, welcome back. In this video, I want to talk about multi-user MIMO channel estimation, but the concept which I want to explain is with respect to two UVs, two-layer case. In the previous video, I was talking about multi-user MIMO concept for two UVs single-layer case. So I had given some high-level explanations, but in this video, let us try to see the similar kind of explanation for a two-layer case, and we'll try to see how to perform the channel estimation and how we should be allocating the DMRS sequence or pilot sequence in case of multi-user MIMO. Okay, so for that, let me take a UV. So having two layers. Okay, now let's say if we have two layers, then definitely what do we need? We need two minimum two antennas at the receiver side, right? Or the base station side. Okay, that is one requirement. Now in this case, uh, DMRS allocation, how should it be? Because here we are transmitting x1 and x2 to ensure that these two are not interfering across the receive antennas. We should be allocating the DMRS sequence on orthogonal resources, or we should be using frequency domain orthogonal cover code like that. So let's say the suitable could be port 0 and let's say port 2. Okay, example I've taken this one for now. Now in this case, so how to perform channel estimation? So our channel will be h2 cross 2, right? And this would be equivalent to MIMO channel estimation. We had seen how to perform the channel estimation for a MIMO scenario 2 cross 2. Okay. um, then after once we estimate the channel, then we would be doing MMSE IRC equalization. So for that, we would use this as a channel estimate, and we will calculate the required MMSE estimator, right? So that there we gonna perform something like H inverse plus I am not going to write the complete equation, but something like that. Then finally we will be applying it to the received signal y bar, right? So this is basically, if you see, this is a 2 cross 2 matrix inversion, and this is for a single UV case for now. So now what will I do is I will take two UV scenario. Okay, so both the UVs are going to have two layers. Okay, so in this case, how should be my DMRS allocations? Okay, before that, in the single UV case, what is the data rate? Okay, let's say as I had taken the OFDM grid. Okay, let me write the OFDM grid at this point. OFDM grid, I had taken just 10 symbols, and in the previous video I had taken 100 subcarriers. And since we have two antennas here, and we are allocating all the 100 subcarriers. Okay, so 100 into 2 layers into 10 symbols, so I will have 2000 bits per second, correct? So this is the OFDM grid across antenna 1, and similarly we will have one more antenna grid for antenna 1, for antenna 2. Okay, now for the 2 UV case, um, how are we going to divide the resources? So we would be doing frequency domain multiplexing in the same slot, right? So which means that mm, this OFDM grid would be divided between the UVs. Okay, so let's say the 50 subcarriers would be allocated to UV number 1 on both antenna 1 and 2, and the other 50 will be allocated to UV number 2. Okay, so in which case across each UV, what would be the data rate? Okay, so the data rate will be half of what we have seen here, so it will be 1000 bits per second across each UV. So we could not actually see more data rate, because we have divided the resources. Okay, so then what about the DMRS allocations? Here both the UVs can be allocated with port 0 and port 2 because uh, we are going to allocate them on the orthogonal subcarriers, which orthogonal subcarriers in the sense, the first 50 subcarriers we are allocating to UV number 1, whereas the remaining 50 will be allocating to UV number 2. Since they are separated out in the frequency domain and there is no overlap, we can use the same port, no problem here. Now what about the base station? So base station can have a minimum two receive antennas. Two antenna is also sufficient, and in this case again for UV1 the channel is 2 cross 2, and for second UV also the channel is 2 cross 2. The UV wise we can perform the channel estimations, and after that we have this MMSE IRC. Even UV wise we can perform MMSE IRC using these channel estimates. So again MMSE IRC will be for UV1 we will have 2 cross 2 matrix inversion, even UV2 we will have 2 cross 2 matrix inversion. So this is all clear for the single UV and the multi UV case. But what about multi-user MIMO concept? Multi-user MIMO concept, in this case, our goal is that we need to ensure we get better data rate. See here, the data rate for the single UV has got decreased, right? Like decreased in the sense like we could able to allocate only 50% of the resources, so we were not allocating anything on the remaining 50 because we had to allocate for the other UV, right? What if I allocate even resources on the remaining 50 subcarriers also? Then there will be a overlap. But in that case, how do we overcome the separation of data at the receiver? That was the question, right? So as I was explaining in the previous video related to 2 UV single layer case, here also if the G node B or at the base station or at the receiver side, if it sees the entire 2 layer 2 UV 2 layer concept into one UV 4 layer. If it sees like it has one UV 4 layer, then we can allocate the resources on complete 100 subcarriers across all the antennas and across all the UVs. Okay, but to do that, okay, let me write it down over here. So let's say we have two UVs, 2 layers each. So in this case, if you want to allocate data on all the subcarriers, then what should be done at G node B? It should see that uh, this as a single UV 4 layers. It should see it in this way. Okay, so you would be receiving signal from all the antennas. If the G node B has to see it as a single UV 4 layer, then definitely this should have minimum 4 layers. Sorry, minimum 4 receive antennas. Okay, 2 antenna is not sufficient, so the requirement is to consider these two UVs as a multi-user MIMO case where these two UVs are paired based on certain conditions. Then the G node B we need minimum 4 receive antennas. Okay, so in this case, what about DMRS allocation for first UV and second UV? So since it is going to be like 4 layer case and we need a separation across all these 4 layers, definitely we should be having the orthogonal allocations on all the four antennas. Basically, first UV can go for, let's say, port 0 and what did I consider earlier? Port 2, right? Okay. Then second UV should not be the same port. We should be going for orthogonal ports. So 1 and 3 will suffice as per TGP spec. Okay. So we will try to see this specific allocation in a moment. Now, at the G node B, how would my channel look like? So it will be 4 cross 4. Okay, so now the channel of UV number 1 and UV number 2 both are combined, and it is made as channel 4 cross 4, and we should be doing the channel estimation in one shot for both the paired UVs. I mean for both the UVs which are paired, and we should be getting channel estimation H hat. Okay, now once channel estimation is done, then we will be doing MMSE IRC in one shot for both the UVs, and in which case we would be having mm, you know 4 cross 4 matrix inversion. Okay, in earlier case we had two UVs. Each UV was having 2 cross 2 matrix inversion, 2 cross 2 matrix inversion, and channel estimations were different across different UVs. But in this case, we will be doing MMSE RC one shot, but that is 4 cross 4 matrix inversion, and also channel estimation is done one shot, considering the combined channel effects of UV number 1 and UV number 2. I hope you got the clarity. So in this case, the data rate is across one UV. What is the data rate? We are assigning all the 100 and two layers, and we have 10 symbols. So 2000 for first UV, even for second UV as well, we have 2000. Whereas earlier, if you see, we had each UV just 1000. Okay, so each EV we had 1000, so we could able to double the data rate. That is the advantage of going for multi-user MIMO, right? Of course, this is done not at the cost of increasing the signal processing too much. There is slightly increase in the signal processing, but still, this is in the acceptable range. Now let us see the DMRS allocations for these two UVs. Okay, two layers. So I was mentioning the first UV that we can go for port 0 and 2, and for second UV we can go for port 1 and 3. So how does it look like? Okay, so as per the GPP, port 1, port 0 means we will have D1, D2. So like that, the allocations will go on. Okay, so here in the E1 subcarrier, it will all be zeros. So what about on the second antenna? So second antenna, it will be port 2 is what I have considered. So port 2, we will have one shift. So D1 and D2, and on the odd subcarriers we will not have anything. Okay. So this side, to the left of this side, whatever I have written is for the first UV. Okay. To have the clarity, I will write it in a different color. So at this point, we will write the allocations for second UV. So second UV, port 1 and 3. Okay, port 1, how does it look? So port 1 will have frequency domain OCC, right? So it is D1, 0 and minus D2, 0. So similarly here minus D2 for the port 3. Okay, I hope you got the this one. This is based on the HTTP spec. In the previous video I was mentioned at what section you will see these allocations for different ports. Now, considering this port allocations, we need to we will receive y bar, right? 4 cross 1 we will receive. We will have at the G node B side we will have 4 antennas. Okay, as you can see here. So now my this one will be channel will be 4 cross 4. Then I should have to estimate this 4 cross 4 matrix. I should have this matrix X, which is 4 cross 4. Okay, so this also we spoke about. We need minimum 4 columns of X to estimate this H, right? Then plus n 4 cross 4. So definitely then if you are considering x 4 cross 4, so we would be stacking up this y, so this will be also 4 cross 4. So but how to get this one? So we need to write the equations over here. So what I will do is for the first UV for port 0. Okay, basically not, it's not just the port 0. I mean, if I go back here, we have y1, y2, y3 up to y4, right? So we would be first checking you know first subcarrier. Okay, let us take first subcarrier. So in this case, what I will say is h11, h um, h12, h13, let's say h14. Okay, so h11 d1. Okay, first UV port 0, then port 2 is here, so the second one is 0 into h12. Then for the second UV port 1, so this is d1 again, so d1 into h13, then again we have 0. Okay, 0 into this one. So like that, if we write for all the others, we will get 4 cross 4 matrix, but I am interested in this pilot matrix 4 cross 4. How does it look like? So similarly, if we write for all the subcarriers, so in this case, how does it look like? 0 d1 and 0 d1. Okay, so how about the other one, d2 d2 0 minus d2 0. Okay, then 0 d2 0 minus d2. Okay, now if you see, I think column of this is orthogonal to all the other three columns. Okay, these two are orthogonal for sure. d1 into d2 minus d1 into d2, this is also orthogonal, so all the four columns are orthogonal. Now this X matrix is suitable to estimate this channel matrix H. So now we can apply the least squares, where in the least square H Hermitian H whole inverse. Uh, then no, how do we do the channel estimation? So X is a here, right? So then which means we need X Hermitian into X Hermitian whole inverse. So this should be given to y bar. This is the least square estimate. So I will get H at here. So this is the least square estimate. So if we apply this one, then and then this will become identity, and this x bar and x, so we'll basically get the channel estimation h. So please substitute and try it out. You will get to know that how we are going to get back this channel estimation. So now we got to know this DMRS matrix allocations and all these concepts. um, I hope you got the clarity over here. um, am I missing any concept? I'm just trying to recall at this point in time. Um, so I hope that's all. I think this is how we should be doing. Channel estimation in case of multi-user MIMO. Okay, one concept I missed it. That is okay. So now we got a chat, right, for cross 4. Using this chat and even many other, like even we would be calculating RNN, noise covariance, and all this, right? So we also saw how to estimate noise in the previous videos. So once we have all these things, we would be going to calculate the weight matrix for MMSE IRC, right? Something like HH emission plus RNN whole inverse. So I will not write. I am not going to write the full equation, but okay, something like this. Now, um, okay, let me write the full equation. I think this will be H emission. So this is H. So now the thing is that once we do this, we're gonna get this X bar at. Okay, this X bar at will be 4 cross 1. on the other symbols where data is present. Okay, we are trying to decode the data here, right? Once we do the channel estimation across the DMRS symbols. Now this this is like x1, x2, x3, x4. How would I know that? Because we have done the MMSE in a combined way for both the UVs and considering two layers. Now how would I know that these two belongs to UV number one, these two belongs to UV number two? How would I know? Okay, that would be that we will come to know in the way we are going to arrange this X matrix. Okay, because we know that for the first UV we had given port 0 and port 2. Okay, considering this only we formed the matrix here. Okay, so this matrix and I mean sorry, this column and this column. So since we are going to arrange in a certain way based on these ports, and we know these ports are allocated to which UVs, by that way we will come to know that the first two belongs to first UV, and that too the x1 belongs to layer 1, x2 belongs to layer 2. Similarly, the x3, x4 would be belonging to second UV. Here even you can actually try to reverse it. Okay, you can bring the third column to first one, and even this the fourth column to the second one. You can try to swap these columns, and then you can still based on the allocations you can still figure out x1 belongs to which UV and which layer. Okay, so this port allocations would be known to both transmitter and receiver. That's how we will get to know okay which data. Otherwise, we will just receive a Y bar. In this Y bar, we will not be in a position to figure out okay which data is where. Okay, that would be known only by uh, allocating the DMRS in a certain way and decoding the data. I hope you got the clarity. I hope you got the full concept of how to perform the channel estimation in case of multi-user MIMO. Even I think you got the clarity on what signal processing blocks would be different and how we should be doing the channel estimation and MMSE IRC in case of with multi-user MIMO and without multi-user MIMO, and even the DMRS allocation is also clear to you with multi-user MIMO and without multi-user MIMO. I hope with the channel estimation I have spoken sufficient concepts. Maybe I will move to a different series from next time. So if you're looking for more concepts and more videos, please do subscribe to the channel. Thank you very much. Have a great day. Bye bye.